Hi guys, I'm Steve Bassi. I'm the CEO and co-founder of Polyswarm. So we're going to talk to you about the blockchain ecosystem, smart contracts, why I'm excited about it, why you might be excited about it, what we're trying to do with it, and sort of how we can, sort of how we can move the space forward. Because over here at Polyswarm, we think that the best way to move this entire ecosystem forward is sort of educate people on the possibilities of how these technologies can be combined and take, take sort of these new tools that we've been given in the last 3 to 4 years and apply them to old problems that didn't maybe have a solution before. So if you can see my slide deck here, I'm going to sort of go through why I'm excited, why I think people listening to this should be excited, and what sort of we're doing with that excitement to turn it into reality instead of just hype. So for the last, I don't know, 10, 20 years since the internet has sort of been a thing, we've had this class of problems that we could solve with connectivity, right? I can transact with somebody in Africa or South America over chat, over the internet. I can use Google Translate if I don't understand their language, and that's all great. But the last sort of problem with this has been it's been really hard to move money across borders and compensate people for work. And if you take the problem that we're looking at, specifically with Polyswarm, it's a lot harder to do that in amounts that are sort of small, say 100 to 200 US dollars a month, right? Moving those amounts across borders is actually really hard with the traditional banking infrastructure. And if you move those amounts, you're looking at anywhere from 25 to 50% of a sub $100 amount being eaten in wire fees, right? So when we send a wire from the States to somewhere abroad, we pay a $25 fee, and then on the other end they pay 15 to 20 just to receive it. So you're looking at $45 to $50 just in wire fees. So we're very excited about smart contracts, and the blockchain is this ability to constantly move money in transactions in sort of any amount, sub $1 US, right, in sort of an automated fashion. So this presents us with a sort of historic opportunity. You get this idea of cross-border payments that no single entity owns. And then this other thing where even if I don't speak, say, Mandarin, I can work out a very simplistic smart contract with somebody that says, if he does something, then pay X amount. If I do something, then pay Y amount. We can wrap that into a smart contract, and either one of us can activate the interpretation of that smart contract, right? Just a little background. Manish, how many of your audience are sort of familiar with smart contracts and blockchain in its entirety? Do you know? All right. Well, I'll just assume no familiarity then. So if you're familiar with what a blockchain is, it's this idea of a shared distributed ledger that people maintain. And this ledger can sort of have a record of many things. And one of those things, with Bitcoin or Ethereum is a record of payments. I sent a Bitcoin from person A to person B, and that's sort of written down into a shared ledger called the blockchain forever. Now, smart contracts add to that, and they say, person A and person B can create this smart contract and agree to it, and they can sort of push a copy of that contract to the blockchain. And when they're ready, they can call that contract, and that contract is interpreted by all the peers, all the participants maintaining the blockchain. Now, the interesting thing here is parties A and B don't actually need a lawyer to interpret that contract. They don't need a judge, a jury, anything like that to handle disputes. Whatever the result of that smart contract is, and the smart contract is written in a programming language, usually something called Solidity, and it's usually the vast majority of smart contracts today are on the Ethereum blockchain. That contract is interpreted at a later date. And the difference between how a real-world contract is interpreted with judges or arbitration or the court system versus a smart contract is interpreted by all the peers running essentially the distributed ledger or the blockchain. the idea behind this um, is that no single jurisdiction owns the interpretation, and whatever the code that was written into the smart contract says, that's the result. Now, since this is running on top of the blockchain, the nice thing about a smart contract is it also has this ability to do things like escrow funds and release payments to peers. So what this means is startups like mine or yours or people that are, or nonprofits or whoever, can create a series of smart contracts that sort of program and create new entire markets without bank fees, without intervention, right? The only fees that are charged are the sort of the fees from the miners on the blockchain, which get to interpret that contract. So this presents us with this sort of historic opportunity to solve problems using both smart contracts and the blockchain. And the way we solve those problems is I don't need to go down to my corner bank and ask them to open an account to pay, to create this new marketplace, or I actually don't even need to incorporate, right? I don't need to create a legal entity in any one jurisdiction. I can just start building marketplaces based on this primitives of smart contracts and the blockchain. So I was in Dubai a couple weeks ago, and this is an example of how they're thinking of using it. They're trying to build smart city applications on top of the blockchain. And basically they have, if you see the highlight there, over 20 use cases under pilot. And what that means is they're thinking of 20 things that they can basically use smart contracts, use the blockchain for, and apply this to this whole smart city problem. So is there a better way to, say, collect tolls on these freeways in Dubai? Is there a better way to manage taxation and property transfer records for property in Dubai, right? These are examples of pilots that I heard from them, and they're interested in using the blockchain piece because this idea of a distributed ledger is attractive. No one body owns it, but several people can contribute to the records of who owns what property, or several people can sort of hook into this toll system that they have for their freeways without having a central authority that owns it. So it's very transparent from where they see it. So, I wanted to sort of go through at a very high level on what we think good blockchain properties are, or good sort of solutions, a solution space for applying this tool of a blockchain with this add-on of a smart contract. What marketplaces, are good for that, right? Because in my travels and sort of other people from my organization, we hear a lot of people trying to apply blockchain to a problem space where it may not necessarily be good for. So let's talk about the good problem spaces. Marketplaces in general that need good borderless settlement. And what that means is any sort of marketplace that is global by default, but doesn't have a really good settlement mechanism right now. And what I mean by settlement mechanism is a way to sort of transact and maybe send small or large dollar amounts to people in several countries or jurisdictions. Blockchains are very good at a trustless, borderless settlement mechanism for that. We also think smart contracts are very good at creating this new sort of framework for a language neutral, meaning spoken and written language, way to create commercial contracts, right? So you have this issue if I want to transact with a guy in, say, Japan or China, right? First of all, I'm fluent in Japanese, but I'm not fluent in Chinese. So what language should we write our legal contract in if we're going to say, trade a ton of rice with each other or some other commodity? That's a good question, right? And then if there's a problem, if there's a dispute with that contract, what language or what court system are we going to settle that dispute in? Smart contracts, in my opinion, obviate all that. They allow us to take these problems or these business deals that we want to sort of wrap into a contract, right? If my counterparty in China does something, then he's owed a payment. If he doesn't do that, then the payment is returned to me. So we're able to sit down and create in very simple terms, if that ton of rice is delivered, pay my Chinese counterparty, 10 ether or 20 ether, whatever the amount agreed on is, right? And the interesting thing about this is if there's a dispute, the contract either encapsulates the mechanisms for that dispute, meaning if I don't agree that the rice has been delivered, my money or my Ethereum that's held in escrow is refunded to me. So that's kind of an interesting dispute resolution mechanism, and we can both activate that dispute resolution through the Ethereum blockchain. We don't need a court, or we don't need a sort of a legal venue to do that. Now, the catch-22 here is that if there's a dispute and we don't agree with the code that's been written into the smart contract, meaning we don't agree with how the smart contract is framed, there may be no way to change that smart contract. So it's sort of permanent and irreversible. And another way of saying this is, in this space, we have to accept that the code we've written into the smart contract is law. So there's another nice problem space that's addressable with blockchain and smart contracts, and trusting the counterparty. Blockchain is very good for sort of creating this distributed idea of trust. I don't need to trust in the Chinese legal system. I don't need to trust in the American legal system. I only need to trust in this idea that a smart contract will be enforced by all these peers across the world who have a vested interest in sort of moving the Ethereum blockchain or moving the other smart contract-based blockchain forward. So this leads us into this idea of bad blockchain problems, right? First of all, I see a lot of people saying, we're going to put health records on the blockchain, or we're going to put identity records on the blockchain. And that's a nice sentiment because we have this permanent immutable ledger of identity or healthcare records or whatever. But when we're talking about things like the Ethereum blockchain, it's very hard to design confidentiality into a public ledger, right? Put another way, when you transact with somebody on the Ethereum or the Bitcoin blockchains, the fact that you transacted and the amounts you transacted in, those are public. They're very public. They're not private. Another bad set of blockchain problems is this idea that you can do very fast settlement or transactions on the blockchain. Sort of the best operating blockchain we have today, that does operation at scale is the Ethereum blockchain with a block time of about 15 seconds. So that's not very good for like a low latency, high frequency trading transaction, right? Where you want sub-second settlement. It's also not good for things that currently can't deal with about $1 or a $2 transaction cost, right? So in our case, we're actually having to put a sidechain solution in for sort of sub-second transactions and very fast transactions. And then this idea of I'm just going to bolt on a blockchain-based solution to some problem space in order to make it look more current and sexy in the eyes of investors. You can see several projects. Dentacoin's a good example of a project. So I won't get too much into what makes a good ICO and a bad ICO. I'm going to kind of skip over that. But in general, any blockchain-based project that doesn't have a team that has relevant business experience in the problem they're trying to solve, you generally want to steer clear of. And also I want to highlight point number 3, which is this idea that that smart contracts in their nature are sort of immutable and unchangeable. So you want to make sure that they've been subject to a security audit, because if there's a flaw in the smart contract that the programmer didn't intend, the security flaw, you've got this issue where it's irreversible and it can't be fixed. So you want to make sure that the team putting the smart contracts out there understands that if they make a mistake in the smart contract development, a security mistake, and that mistake allows some unrelated third party to collect all the Ethereum in escrow or collect all the funds in escrow with that smart contract, then unfortunately you're out of luck. That's irreversible. And you can see sort of examples like this in things like the DAO or the Parity Wallet hack, where funds were essentially frozen or locked up because someone didn't perform the appropriate security audit on the contract itself. So in summary on what blockchain and smart contracts are good business or sort of good tools for business problems against, this idea that a distributed ledger should help, and it should help the business case. And you don't really want to bother with smart contracts if a traditional contract will do, right? Because smart contracts are actually expensive to develop, and the cost of mistakes can be high if you don't sort of put a corner case in there. Also, this idea of, as you're thinking of what problems and solutions blockchain and smart contracts can apply to, is there a case for doing borderless global interaction without the intervention of the traditional structures? So this other idea that ICOs out there, what they're really trying to do is solve problems with existing markets, or problems with existing ways business have been done. And in our own travels, we spent a long time thinking about the game theory of how our market is designed. Put another way, the game theory to us means we want the market to be what's called thick, meaning there's lots of opportunities for participants to transact, and also safe, which means that for the participants in the marketplace, they're not going to get cheated or gamed by other participants based on the way the market's designed. So we spent a long time thinking about the game theory behind this and how to make these two things possible for our market participants. If you want more information on market design at a high level, there's a great book called Who Gets What and Why. It's by Alvin Roth, a Nobel Prize-winning economist. Really recommend it as a good weekend read. It talks about sort of market design for organ donation, all the way to school lotteries. There's several things in there that are very useful in this idea of where smart contracts and blockchain might be a good fit. When you're designing these things, you have to remember that bad actors on the internet, they exist to abuse marketplaces like ours and other ICOs that are sort of blockchain and smart contract driven. Their goal is to profit, right? And people out there are not necessarily looking for good outcomes for their market counterparties, but frankly, they're just looking to profit occasionally. So good ICOs and good solutions to smart contract, or sort of problems out there, business problems that may be able to be solved with blockchain, smart contracts, related cryptocurrencies, they make cheating expensive. And they look at the security piece, because you don't want to ignore the security of the marketplace, because that basically opens it up for game theory and abuse. So I'm going to talk to you a bit about how we did things in our marketplace and how we see development here. And I also want to point out a smart contract based solution for what we're doing, or sorry, for what someone else was doing, and how that was abused. So I'm going to walk you through a smart contract for a interesting game on the blockchain, and talk to you a bit about ERC20. So ERC20 is basically this idea of a token ledger within a broader ledger, right? So this idea that you can create a subledger that tracks a completely different token or currency or any sort of marketplace you want to define. And what ERC20 is a standard on the Ethereum network for smart contracts, which basically allows you to define your own sort of ecosystem's currency. Really, it's just a smart contract with programmable functionality, and it's this idea that you can define things like a total supply of tokens. You can define rules about how those tokens can be transferred, and you can basically give that a well-defined interface that a bunch of Ethereum wallets and other software knows how to interact with. Now that interface is called ERC20, and it has, I believe, 7 functions that define things like total token supply. It defines another function that allows you to transfer tokens from point A to B, and it defines other functions that sort of allow you to name your token and describe other aspects of the token. So I want to get to this idea of a first smart contract that sits out there and that had a security flaw. And I want to address why it's very easy to shoot yourself in the foot when you're talking about smart contracts and when you're talking about programming them. So this is a contract called Rubixi, and Rubixi is basically allows the owner or people to contribute to this, what essentially is a pyramid scheme. Ignore the humor here for a second, but it allows basically people to contribute to this, and then the owner to collect fees over time. Very simple contract, right? So if you'll notice two things, every contract on the Ethereum network has this idea of a constructor. Now in this contract, the constructor is supposed to be named something called Rubixi. It's supposed to be where the function dynamic pyramid is. However, what happened here is this contract owner just simply copied and pasted a contract that used to be called dynamic pyramid and changed the name to Rubixi. What he neglected to do is he neglected to change something called the constructor to also be named Rubixi. So what a constructor means is when the first time a contract is deployed, the constructor is called only once and is allowed to set a few initialization parameters. In this case, those initialization parameters were supposed to be set in that function called dynamic pyramid. And very simply, it allowed the creator to be set to the person who deployed the contract in the first place, specifically the owner here is what we think of that as. Now, if you look further down, lines 18, 19, 20, starting there, the contract allows you to collect fees, but it only allows you to collect fees if you are the owner, right? So that's very interesting. So the mistake that was made here was that the owner neglected to change the function dynamic pyramid to a function called Rubixi and therefore make it the constructor. Now the flaw here is that any function with a capital letter in the first case, or in the first, the first character of the function name, is allowed to be called by the public at large, right? And in this case, the public at large is allowed to call this function and set the creator or the owner of this contract to themselves. So what the exploit looks like here is basically the owner of the contract is able to call in to dynamic pyramid, or sorry, anybody in the public is able to call into that function, set themselves as the creator, and then the very next thing they do is hit the collect all fees function, which basically allows them to sweep all those fees into their account, even though they're not the owner of the contract itself. So that's sort of a very simple example of how it's easy to fail in creating and maintaining smart contracts. So back to projects, how to evaluate them and how to think of security. So it's very simple to see from the last contract that you want leadership or teams in place if you're considering some ICO that have a plan with respect to security. It's also very clear that it's very simple to make mistakes in smart contracts. You want several eyes looking at it. So why do I say all this? It's because my team and I, we have a lot of experience in security. Very specifically, we've got a large bench of security expertise, and we took that to the problem set we were trying to solve, and that's Polyswarm. Specifically, Polyswarm. There's the team. Hi, team. Specifically, Polyswarm is looking to address a problem with the antivirus economy. The way it exists today, it's broken, right? And we have this issue that computer and data are compromised by malware, but single vendor, basically the people who provide antivirus software out there are only single vendors, your McAfee's, your Kaspersky's, your Symantec's, right? And unfortunately, those single vendors, they try to protect their customers as best they can, but they don't cover the global space of how malware is created and released over time. So what this means is that if you're a McAfee customer and you are paying them for protection, essentially from malware for the year, and they happen to miss a new virus that comes out, but say Symantec or Kaspersky picks up on that virus, you as a McAfee customer are not protected. So we think that's wrong, and we are basically trying to leverage the blockchain plus smart contracts to assemble this idea of a more global antivirus coverage. And we're basically taking this idea that there's a global body of security expertise out there, and they can't all move to the US or to Russia and work for, say, a McAfee or Symantec. But what we think they can do, we think they can maintain smaller pieces of antivirus software we're calling micro engines. And we think that for those, for that maintenance and development, they should be paid a small fee every time their micro engine detects a threat or detects a piece of malware that's out there in the world. So in depth, what we're trying to do is essentially crowdsource antivirus. And we're leveraging this global community of security experts and trying to compensate them or pay them for this idea of developing and maintaining smaller pieces of antivirus software that ultimately protect the user from threats. So in our case, we've developed a token called Nectar, and it's basically this token is given to anti-malware experts and their software when they detect new malware. So we spent a long time thinking about this compensation model and how we could leverage smart contracts and the blockchain to compensate our expertise. So why did we do this? And we spent a long time thinking about the cybersecurity market. And very simply, every time you browse a URL or open a file attachment out of email, the odds are, even if you're not running antivirus software on your computer, that somewhere along the line that file or that URL was scanned either by your internet service provider or your enterprise or your company for threats. And this happens billions of times daily, and we end up paying about a half a US cent to a cent and a half for that scan. Unfortunately, like we discussed earlier, Symantec, McAfee, Trend Micro, all of these companies out there basically provide antivirus services, but it's a fragmented market, and they don't provide this sort of common umbrella that protects the users from threats. So we're basically looking to disrupt that approach and create this global cadre of security expertise that protect users from threats. Now, the advantage here is that we don't require a middleman or traditional banking infrastructure to compensate experts. So this means we can access experts wherever they are. And we don't have to pay attention to this human language barrier because we're basically asking them to write software and get paid via a smart contract that's interpretable by anybody, no matter what language they speak. So I want to go through a bit how we sort of define the players in our ecosystem. And I know we're running a bit short on time, so I'll sort of look towards wrapping this up after it. And, you know, I don't know if I'm supposed to provide a forum for questions here or not. But we have, you know, this is sort of key to defining any smart contract-based market. We have this idea of the players in our marketplace, and they are ambassadors, and these are existing information security companies or something called managed security solutions providers who already supply consumers and enterprises with sort of complete protection solutions from firewalls to antivirus software. Then we have security experts over there on the right-hand side, and we have end users on the lower left-hand side. These are either companies or individuals who today consume antivirus software. So the idea is that either end users or ambassadors promote or post automatically through their antivirus software bounties or offers. Now, bounties are sort of like this idea of, hey, I have this file, and I'm not really sure if it's malicious or not. So I'm sending a small sub-cent amount of money out along with this bounty, and I want the security experts and their software to respond to that threat or respond to that potential threat by offering a prediction whether or not they think it's malicious or not. Now, if they're correct in this prediction, then they get rewarded with our Nectar token. If they're incorrect, they get they lose whatever they have staked in their prediction, and they basically stake their predictions in the Nectar token to the winning side. And the party we use to make that determination are called arbiters. We'll get to them a bit more later. So again, to recap, you have enterprises and home users, and they have money, and they want sort of timely protection from malware for their users if they're an enterprise, or from themselves if they're a consumer. Then you have this player, these security experts, who their job is to write and maintain smaller pieces of anti-malware software, essentially, that predict whether or not things they see, these files that you see with the X's and the check marks, whether or not those are malicious. The last people we have are ambassadors, and they sort of provide an aggregate point that enterprises or enterprises or end users can communicate with in order to sort of get this aggregate knowledge from security experts in a very digestible fashion. What I mean by that is that if 10 security experts are predicting if something is malicious or not, and 7 say it's malicious and 3 say it's non-malicious, how do you interpret that result? Do you just take a majority vote and sort of and say, oh, the 7 people thought it was malicious and the 3 people thought it was non-malicious, so we will essentially think it's malicious. So the ambassadors are sort of responsible for interpreting those results and providing them to either the enterprises or the users. And for this, they receive a small fee on every artifact that's predicted on. But for that fee, they basically provide simplification of the results. So we built our system up with these 3 components, and the idea is that going forward, we would be a viable replacement for antivirus. To the audience out there, I want you to think of other ways if you're a developer or a business person, you may be able to provide value to either our security ecosystem, our development ecosystem, or the other ways that you may be able to create a smart contract and blockchain-based solution for other problems that exist out there. A lot of this, and we've seen this time and time again, requires this idea of community building. This idea of, if you're creating a decentralized solution based on these technologies, you actually need a bunch of participants out there to maintain this solution. So I want to sort of stop here because we're out of time. We are just finishing our public token sale right now. So if you're interested in Polyswarm or how you can get involved, there's a lot more information on polyswarm.io. Encourage you to read the white paper. Pop into Telegram if you've got any questions. We've got a large set of community management there. I wanted to talk a little bit more about our token sale and how we build that in general. But I think I'll just end here and say, in the blockchain smart contract-based ecosystem, it's really all about people building solutions from things that are already known problems but don't have a known solution. So I encourage you to get involved. Thanks for listening, and happy to chat further via email, Telegram, or any of the other sort of many communication mechanisms the internet provides. Anyway, thanks for listening. I'll stop here.